You've heard of them. They make you into an addict, they give you pleasure and make you move, they relax you, and even can make you fall in love. Whether it's dopamine fasts to get more energy and focus, or some motivational speaker telling everyone to be kind to others, because that will trigger the release of oxytocin in our brain and make us feel happier, we hear about neurotransmitters all the time. What they do to us or for us. But how much do these people actually know about neurotransmitters? And how much do you know about them? Today, I want to tell you what neurotransmitters are, how they function in our brain, and all the different types of neurotransmitters out there. And at the end of the video, I'll go through a few of the myths of pop science you likely have heard about to let you know what the science is really saying. But I want to keep this video short, so let's get into it. When two neurons want to communicate, they need a way to do so. And, much like different communication channels are more appropriate for different types of information in our world, different types of neurotransmitters are adequate for different types of messages. There is still a lot we don't know in this regard, because the same type of neurotransmitter might have completely different functions in different brain areas. But, in essence, there are two different main types: small molecule neurotransmitters and neuropeptides. And just like we generally use text messages for fast, more informal communication and emails for more professional and slower communication, neurons also have a faster and slower communication system. Specifically, small molecule neurotransmitters, called that because they are the smaller of the two types, are also the faster acting of the two. Although they act faster, their effects also dissipate faster. Because they are small, production of these neurotransmitters happens in the axon terminal, and some of them can be reused after the synapse has occurred, while neuropeptides can only be used once. These small molecules are composed of three different types. The first one, biogenic amines, like serotonin, dopamine, and adrenaline, regulate emotion, reward-oriented behavior, sleep, stress, and many other states of mind and basic brain functions. The second type of these neurotransmitters are the amino acid neurotransmitters, like glutamate and GABA. These two are pretty much universal transmitters in the brain, and are fundamental for most excitatory and inhibitory connections in the brain respectively. Finally, acetylcholine has its own special type, and for a good reason. You may not be familiar with this transmitter, but it's responsible for pretty much all automatic behaviors of your body. It was also the first neurotransmitter to be found in experiments, so you know, kind of a big deal. Meanwhile, neuropeptides are bigger in size, act slower, and have a longer lasting effect, because they actually alter the gene expressions in the cells they affect. Because of their bigger size, these neurotransmitters are made in the cell body of the neuron and can bind to a larger amount of neuroreceptors, while the small molecules can only do so with a specific type of receptor. Examples of these include oxytocin and insulin. As mentioned before, these have longer lasting effects, with research linking them to mood and anxiety disorders. A review article will be left in the description if any of you wants to know what the other differences between them are. But for now, let's see some examples of what we commonly hear about them and their influence on us. I'll do my best to explain why they are true, false, or if research on those topics is still inconclusive. I'll probably do a more in-depth video on these topics in the future, so let me know if you'd like to see one. We'll start with dopamine and why it isn't the chemical responsible for pleasure as many think it is. This might very well be the most prevalent myth I see around the internet, despite what a lot of pop psychology articles might have you believe. Dopamine isn't responsible for feeling pleasure in of itself. I mean, you can even feel pleasure without it. So this is definitely a myth that needs to be squashed. In reality, it is difficult to pinpoint exactly what it does, but one of the most prevalent ideas is that instead of being responsible for pleasure, dopamine is instead a neurotransmitter responsible for motivation or action, as a lot of research has found its functions in the brain can be related back to motivating the individual to act, learn, and memorize actions and behaviors that are beneficial to them. If you want a scientific review of these two arguments I'm discussing here, you can find it in the description. I might make a full video dedicated to dopamine in the future, so let me know if this is something you'd want to see. The serotonin theory of depression has become pretty much an accepted truth by the general public, with a poll showing around 80% of people believing that serotonin is their neurochemical responsible for depression and mood disorders. This might then surprise you to hear that it isn't actually an accepted fact in scientific circles, where more and more reviews of findings are showing that either studies find no significant evidence of this, or they are badly constructed, and consequently their findings bear no weight due to not being reproducible. A review that came out this year from the University College London showed how, among the 4 possible ways serotonin could be implicated in depression, only one has produced positive results in past studies. However, this review also showed that these studies supporting the serotonin theory of depression were badly constructed and didn't include people who weren't on antidepressants at the time, which is obviously a requirement to consider their findings actually relevant to this discussion. Now, there is, of course, the fact that SSRIs work for some people who are suffering from depression, which is actually the original reason why researchers started to believe the theory connecting serotonin to depression. However, as pointed out by another review from 2015, this might be a result of an indirect relationship. You see, serotonin is involved in increasing plasticity in the brain, which is essentially an academic word for learning. Now, what this review suggests is that by increasing the rate of learning, SSRIs actually increase the capacity the person taking them has to relearn the emotional associations they created whilst suffering from depression. This capacity, when paired with work to relearn these associations, can then give way to the known gradual onset of antidepressant activity. Unfortunately, I can't get into this topic too deeply right now, but in short, if you have to believe something, then I would err on the side that a lack of serotonin is not responsible for depression. However, increasing serotonin in the brain might help get out of it. But once again, this isn't so clean-cut, as we can see through how SSRIs help some people whilst not having an effect on others. I know this is the 3rd time I'm saying I'm gonna make another video about a topic I'm covering, but I will definitely make a video about this topic, because there is way more to it than what I was able to explain here in a few minutes. As I hope you can see, there is still much we don't fully understand about neurotransmitters and their role in the brain. Not only that, but because of their influence on us, there is still a lot of bias involved, especially when the general public is concerned, where scientific articles and findings usually get taken out of full context. Because of this, I will definitely be making more videos about this subject. I mean, it is very interesting to me, as it is to so many other people, so be on the lookout for that. But until then, feel free to explore the references to delve into what the science is saying, and I will see you in the next video. Take care, and remember to like and subscribe if you liked it.